Welcome to GCSE Product Design Influences, topic number 9, Systems and Structures. Now in the textbook this is quite a small section, but it kind of details quite a lot of stuff that may sort of come under it. So it's kind of a throwaway paragraph in the textbook, but just to be thorough, I have put together some stuff that should hopefully cover anything if a question does pop up about it. Okay, so I'm going to start off by looking at systems. Okay, first thing you need to be aware of is the definition of what a system is. Okay, a system is a collection of connected things which perform a task. We're surrounded by systems. So some of those are people. So for example, the teachers at the school are part of a system. Some of them are sort of physical systems, things that are connected together, whether that's burglar alarms. But it could also mean mechanical things that are collected together, as well, as you can see in this diagram here. So the parts of a system, the three parts of a system are what we call the input, the process, and the output. Okay, and we need to have these definitions so that we can use a system to explain how things work. So by breaking them down into these three boxes, okay, input, process, and output, we can use this to explain how these interconnected things actually work to produce things. So for example, if we look at a braking system of a car, the input is the driver putting their foot on the brake pedal to exert pressure. What actually happens when he does that, hydraulic fluid forces a piston to activate, and that piston then squeezes the brake pads onto the brake drums and it slows the vehicle down. Okay, so three parts. You push the pedal down, this is what happens, and the car slows down. Okay, and as you can see here, this is all the parts we just spoke about in that system. So that's quite complicated. So you can see how by breaking it down, okay, there's the brake pedal there, so that's the input. All this is part of the system, the process, and then the output is basically the car slowing down. Now, we often refer to something called feedback in a system. Sometimes fine control is needed, and this is where feedback comes into it. Feedback is information that's sent back into the system, and the system will actually change if it needs to, depending upon that feedback. Okay, so to look at that again, if we look at input, process, and output, feedback actually goes back into the input, and the whole system will adjust itself. Okay, once you introduce feedback, you then have this idea of what we call closed and open loop systems. Okay, so a system that's got feedback in it is a closed loop. If you look at it, the information cannot get out. That's why it's called closed. It will just keep going around and around and around. Whereas a standard sort of basic system is called open. Okay, it starts and it finishes, end of. If you want some examples of products, then a toaster is an excellent example of an open loop system. Okay, in other words, you turn it on, it heats the bread up and toasts it, and then it pops it out when it's done. That's it. Okay, it doesn't pop the toast back down again, alright, just in case it's not warm enough. So it's an open loop system. Whereas your central heating at home, okay, the thermostat, is what we call a closed loop system. Alright, you set the temperature on the thermostat and the heating comes on, and then a temperature sensor inside the thermostat monitors the temperature and provides feedback to the system. When the house is warm enough, it turns off. If the house is too cold, it turns on, and that closed loop keeps that system going for as long as you want it to. Now, when we talk about systems, you may come across a question that asks about a subsystem. Okay, basically a subsystem is a smaller system inside another system. So for example, if we looked at the system diagram here for a burglar alarm, okay, obviously the output would be some sort of flashing light, sort of siren. However, feeding into the process might be a door sensor, a window sensor, or a panic button. These individual parts here are subsystems. Okay, so for example, the sensor on your door is a subsystem of the whole sort of burglar alarm system. Likewise, the window sensor is also a subsystem of that whole system. Okay, hopefully that's made that clearer. Second part of this topic, then, we need to look at structures. Okay, now structures can be categorized into two different areas. These are man-made structures, okay, bridges, houses, planes, all that kind of stuff, and natural structures, okay, eggshells, honeycomb, leaves, all right, spider webs, okay, structures that occur in nature. All right, so man-made and natural structures. Obviously, what we're interested in is the man-made structures. Okay, the first of these are what we call frame structures. An example of a frame structure would be an electricity pylon, like you see here. This is where basically the shape is made up of lots and lots of smaller sort of parts, or what we call struts, to create like a framework for the structure there. The second most common structure is what we call a slab structure. Okay, this is where you've got sort of larger flat pieces of material that come together to create a structure. In this case, a bookcase is a good example of a slab structure. You may come across something called monocoque or a shell structure. This is where a single material is actually used to create the entire structure in one continuous piece. So for example, a drinks can, like a Pepsi can here, it's one single piece of aluminium to create that. This egg box case here is a single piece of cardboard. Same with the milk container here, or this fiberglass body for a car. Okay, it's a single material that's molded in such a way that it just provides like a shell to the whole structure. You also need to be aware of flexible structures, which are quite a modern invention. All right, things like bouncy castles, things that only achieve their sort of structural shape when they've actually got air inside of them, and then they stay quite rigid. Okay, so bouncy castles, inflatable cars, you can get paddling pools. They can also be inflated, can't they, to create the structure that way. I used to have an inflatable baby bath when my children were small that we could take away with us on holiday. You just blow it up and hey presto, you've got a bath. Now if we just dwell for a second on frame structures, the whole point of a frame structure is it relies upon the strength of all its joints to actually hold itself together, and a triangular structure is actually the sort of strongest shape you can get. Alright, so to make frame structures strong and rigid, you use this idea of using these triangles, which is called triangulation. Okay, and you'll see that in all these frame structures. Okay, so in the pylons there, they're made up of triangles. Got a bridge here, you can see the triangles that help make this structure nice and rigid. Eiffel Tower, yeah, millions of triangles on the Eiffel Tower. And even here on a simple gate, you can see how just by putting this diagonal cross beam across here, we've now broken this shape up into 4 triangles so it's rigid. Okay, so you've got a question in your question booklets to try now. Again, starts off with the design feature type question, just to get that into your heads, because you always need to practice them. So 3 features of an egg box. What does an egg box have to do? Obviously it's got to protect the eggs. Okay, so I'll give you that one for free. Now the egg box is what we call a monocoque shell structure. Okay, so look back over your notes and explain what that means. Okay, monocoque or a shell structure. And then can you give 2 examples of products, not food, okay, other than food packaging, that have a monocoque structure? Okay, so like a single piece of material that creates the structure itself. Okay, thanks for listening. Don't forget to like and subscribe, and get on with that question. Thank you.